Every AI coding assistant today has the same dirty secret. When the agent writes code and runs it to check the result, it runs that code directly on your machine. Your files, your credentials, your system. One hallucinated shell command away from disaster. Lula fixes that at the architecture level, and the way it does it is worth understanding. Lula is a multi-agent coding assistant built around a sandboxed Rust execution engine. That means when an agent generates code and needs to test it, the code runs inside an isolated environment, not on your host system. The sandbox is written in Rust, which means it's fast, memory safe, and genuinely difficult to escape. This isn't Docker with a prayer. This is process-level isolation baked into the tool's core design. Here's what that looks like in practice. You give Lula a task, say, parse this CSV, clean the data, and output a summary. Lula spins up multiple agents. One plans the approach. One writes the code. One executes it. But that execution agent runs the code in a sandboxed environment it cannot escape. If the code tries to read your SSH keys or phone home to some server, it hits a wall. The agent sees the output, passes it back to the orchestrator, and the loop continues safely. The multi-agent structure matters here. These aren't parallel threads doing the same thing. Each agent has a role. The orchestrator coordinates. The coder writes. The executor runs and reports. This separation means errors stay local. A broken execution doesn't corrupt the planning context. You get cleaner debugging and more predictable behavior than a single monolithic agent trying to do everything at once. What surprised me was how the Rust engine handles speed. Sandboxing usually means overhead. But because the isolation layer is written in Rust rather than spinning up a full container runtime, the latency is genuinely low. You're not waiting for Docker to initialize. The sandbox is lightweight by design. Now let's be honest about what Lula does not do, because this is where most tool reviews go quiet. First, it is not a finished product. This is an early-stage open-source project. The agent coordination is functional but not polished. You will hit rough edges. The documentation is sparse. If you're looking for a plug-and-play cursor replacement, keep looking. Second, the sandbox scope has limits. The Rust execution engine protects your host system from the code the agent runs, but it does not protect you from what the agent does at the API or prompt level. If an agent decides to make an external HTTP call that's allowed within the sandbox config, it can do that. You need to configure boundaries deliberately. Safe by default is the goal, but you still need to understand what you're enabling. Third, multi-agent systems are harder to debug than single-agent ones. When something goes wrong, and it will tracing which agent made which decision requires logging discipline that isn't fully built out yet. This is a known hard problem across the entire multi-agent space, not just Lula. And finally, Lula currently focuses on code execution tasks. It's not a general-purpose assistant. Don't expect it to draft your emails or summarize documents. It exists to write, run, and iterate on code, and that's the scope it's targeting. What could Lula realistically become in the next 12 months? The sandboxed execution primitive is the valuable part. Imagine a world where you let Lula agents loose on a codebase, not just writing new code but refactoring existing modules, running test suites inside the sandbox, catching regressions before they ever touch your environment. That's a plausible near-term use case if the execution engine matures. The multi-agent architecture also opens up interesting deployment scenarios. If you're building an internal developer tool and you want to expose AI coding capabilities to your team without giving those agents access to production systems, Lula's sandboxing model is exactly the kind of primitive you'd want to build on. You could wrap it in a DigitalOcean droplet, expose a controlled interface, and let engineers query it without ever worrying that an agent hallucinates a destructive command. There's also a path toward agent specialization. Right now the roles are fairly generic. But if you could define custom agent types, a security auditor agent, a performance profiler agent, a documentation writer agent, each with its own sandboxed execution scope and permissions, you start building something genuinely powerful for engineering teams. So why does Lula exist? Because the trust problem in AI coding tools is real and mostly ignored. The demos look great. The benchmarks look great. But nobody talks about the fact that when Copilot or Claude or any other assistant executes code, it's executing it somewhere. In a lot of setups, that somewhere is your laptop. Lula's creator looked at that and decided the architecture itself was wrong. Not the model. Not the prompt. The architecture. That's a fundamentally different starting point than most coding assistants. Most tools start with capability and bolt on safety later. Lula starts with safe execution and builds capability on top. Whether that trade-off pays off depends on how much the execution engine matures, but the instinct is correct. If you work in an environment where running untrusted AI-generated code on production-adjacent machines is genuinely scary, and it should be, Lula is worth watching. Not deploying today, necessarily. Watching. Next episode we're looking at an open-source tool that replaced a paid data pipeline worth $4,000 a month with 40 lines of Python. Subscribe so you don't miss it.